Hey, it's Jordan here. Hope you're doing well, and just wanted to firstly apologise for not posting for the last few weeks. Um, just kind of got delayed with the post with this video, but I wanted today to remind you that there's a new version of Base R. Okay, so let's have a look at that. It's 4.6.0. I'm not sure what date this came out, but it was definitely since my last video. When you want to update your base R, you just need to go here, click that, and it will be a download in your download folder. That's on this website here, okay? You can kind of just search for it though, just install R for the first time, or install R, we'll find it in the options. You don't need to overwrite the, you don't need to uninstall the R that you already have on your computer. You don't need to uninstall anything, you just need to install this and it will overwrite the previous version. In R itself, in RStudio, of course we're using RStudio instead of base R, which is not kind of ideal to work with, in my opinion. We can make sure that we're using the newest version of base R through the global options, the tools global options, and we can see here that I am using 4.6.0. Choose a specific version is here. I guess you have, if you have other versions in your history on your computer, they might also show here, but we make sure we choose 4.6.0. And it's beneficial to update base R, RStudio, and all your libraries frequently. At least make sure that you check that occasionally, because as well as packages updating, there are some packages that only work in newer versions of R, etc. So there's lots of reasons to update. We're good for that. Today I wanted to look at a data frame which is pretty close to what I used to work on in my academic studies. So this is data, it's a library that contains data on Plankton. And for that special occasion, I'm even drinking from a coffee cup that says keep calm and focus on copepods. And it's got a picture of a copepod on the back. So cheers. And just in case you didn't know, copepods are hugely important in the oceans as food for so many creatures, and very, very important for carbon cycles and stuff like this. But the data frames that include data on Plankton are part of a library called planktonr, okay? And in order to kind of like draw your attention to a potential issue with installing that library in 4.6.0, I uninstalled that library, and now I'm going to try and install it again, okay? So, see, you notice something's happening now. When I'm obviously in the install button here, right? Install in the packages tab. When I start typing plankton R, which is the name of the library, it's not suggesting anything. So that's telling me that already it's not able to find this library. So we'll just see what happens if we click install here. Alright, it says Plankton R is not available for this version of R, which is strange, okay? And you might have seen that kind of issue. It's not, in this case, it's not just a warning message, it didn't work, it's an error message. And if you've had this problem before, I'll show you how you can fix it. Now, I'm not going to go, I don't know about the details for why it's not available for this version of R. I'm not entirely sure, but there is another way around it. And that is to have a library on your computer called remotes. Okay, So we'll just obviously, as you know, put all the libraries that we're going to be using in a session right at the top, and it's starting to suggest here remotes. Okay, so when that's installed, what we can do is we can use it to install from GitHub. Okay, and GitHub is where you can get the packages from. Alright, so I've just went into a new Chrome browser here, and I've typed in planktonr GitHub. And incidentally, you probably want to write GitHub here, because if you just type planktonr, because plankton R in R in the R software is not particularly well known. It's difficult to find it that way. So add GitHub to the end, and now we can, what we want to do is we want to put R there as well, because I think this is the one we're looking for. Right, it's produced by the developer, it's called Plankton team. Let's just look at this library a little bit more. You remember that GitHub is where you can directly install libraries from. Normally I'm not doing that technique. I'm just, where possible, installing it through the install button. But this allows you to take them from GitHub. And if you scroll down about halfway through the page, for this web page and any other web page that's on GitHub, you can find much more information about the package, about the library. And that even includes code that you can use within that library. It's going to be crucial when you're installing a new library that you've never used before to discover what codes they're using and what codes constitutes key tasks within the library. And we will at least do something like this today, bring in the data from the internet using pr_get_nrs data. In addition to that, you can get acknowledgements. Alright, so this tells us all about this, where it comes from. And you can kind of see that some of the stuff here that's suggested as code is not code that's exclusive to this library. I mean, this is dplyr, right? That's why they load dplyr here. All they're doing there is filtering. I'm more interested in code such as this, which seems to be unique to this library. Okay, so we want to get it from here. On GitHub, okay, the name of the developer is followed in the kind of like first thing you find on Google. Name of the developer is followed by / and then the name of the library. That's the general style for all libraries, as far as I can see, or for most of them on GitHub. Like for example, if we just took another one, dplyr or GitHub, yep. So they all kind of have this kind of style where it has a / between the developers and the name of the library. And we can use that here through library remotes. If we type in the code install, okay, then it starts to suggest things _GitHub. All right, we've got the brackets here, and then you just put exactly what appeared there. Plankton team / plankton R, and we'll just make sure that that's what's shown there exactly. Yes, Plankton team Plankton R, and that's what it's looking for. Let's try this now. It's looking good. And my studies were partly on this. Okay, I did a postdoc on this. This is a COPAPod, right? And I did it on Calanus species especially Calanus fumarcus, which is found in the North Atlantic. But my PhD was on arrowworms, okay, which eat copepods. And all these creatures, I mean, they don't just eat copepods, they eat plant material or diatoms as well. Okay. In fact, this data frame that we're going to be viewing here is going to contain a lot of phytoplankton species, and all of these are crucial for making the food web work as it's supposed to. All right, so it's worked now, and after that, then we can hashtag this out because we won't need it anymore. And now we can see if we can load the library planktonr. And it's worked. And remember that triangle is a good sign. It means it has worked. So as that website suggested, we need to use a specific code to bring in the data. And if you go back here, we can, as I said, this is going to be data on species in different places. I haven't looked too much into the details of where the species are coming from, and it doesn't matter. It's mostly to show you how to use install_github. It's this part that's crucial here, okay? We can put as.dataframe in front of that part, and that's going to put it into a data frame instead of showing it into the console. In general, you always want to do that, okay? And if you do that, you've got to call the data frame a name, call it whatever you like, but I'm calling it plankton data here. So that will bring in the data, or a bunch of data on plankton abundances. Okay. It said that this code that was shown on the website is deprecated in a recent update to the library, but it still works. So if it ain't broke, don't fix it. And I'm okay to keep using that for now, until it stops working entirely, but it did bring in the data. And what data did it bring in? 925 total columns, guys. So not that many rows, you know, still a lot, 1,431. But that's nothing compared to the likes of diamonds that has 50,000. The difference with diamonds is it's got nowhere near 925 columns. It's got a lot of rows though. So from the look of this, it's got all this information about stations at which samples of plankton were collected. And in addition to that, it has information about the temperature and the chlorophyll, okay, and the salinity of the water, and also it has information about different methods. So it suggests that these plankton abundances that we're just about to see in a second were collected using different methods. And then if you kind of scroll a little bit further, so about here, we start to get into species abundances, and it starts with the species called Acantharia, and it has abundances here. Again, as we often see in our data frames, the units are not shown, but you would just go back to the GitHub page to hopefully find the units for these numbers. And I mean, interestingly, if you scroll up and down on any of these columns, you see, I'm getting the idea that there's a big range in numbers, okay, in the abundances. And I mean, I'm expecting some of them will have abundances, probably individuals per meters cubed or cells per individuals, cells per meters cubed, although I'm not positive about that. That go up to thousands, tens of thousands, or even hundreds of thousands. Other ones won't. Everything's in alphabetical order for the different species. Note that these names have spaces between the genus name and the Latin name. Okay, that's kind of simple biology always has two parts of the name, you know, for all species. and the polar bear, for example, is Ursus maritimus. This is a genus part, and this is the species part of the name. This space could cause problems for things like ggplot if we wanted to plot that column directly in ggplot, because ggplot doesn't like quotation marks around the name of the x column and name of the y column, and it also doesn't like spaces in the name of either of those columns. So we'd probably do a rename here to turn that space into a dot. Another option, which we can talk about in a second, is writing this data frame to the computer and bringing it back in again. Might do that. Okay, so look, this Alexandrium's got abundances up to 1930 there. And because this data frame is so wide, it's got so many columns, you're going to have to push left and right here on the little triangles to scroll through all the different species. And this one here will take you to the end. Hence why, so the double triangle will take you to the Zs, and anything else that has symbols, for example, should be at the end of the data frame. So let's do this now. Let's write that into the working directory as a CSV file. Okay. Remember that if we export a data frame as a CSV file, okay, to the computer, then this is a little hack, because when we bring it back in again, it will turn spaces in the column names into dots, and that can be useful, you know, if we want to change that for all of the columns, with the spaces in the names of the species. So I can't remember if we did this before, but we're going to type, if we want to export it as a CSV, we just do write.csv. Firstly, in the brackets, the name of the data frame. That's the first part, and the second part is whatever we want to call it on our computer, followed by .csv. And for me, there's no reason to call it anything different than what we've called the data frame name. So I would not change this. You can call it whatever you like, but again, make sure that it's not something like data or data 1 or data 2 that won't mean anything to you later. This is going to save directly into wherever we set as a working directory. And we talked about this at the beginning of the YouTube series. You always want to make sure in every session that you go into the session menu and you choose your working directory. Okay, I've already created a folder on the computer called planktonr. I should note at this point that I'm not associated or affiliated in any way with the developers of this library, okay, or any code that anybody's ever made in R. I kind of just want to say that because I don't know how good this data is, but we're just using it for the purpose of learning stats and learning R, okay? But I've created a folder here called planktonr. That's my working directory now. And when you run this line, it has worked and it's done what we wanted. It's put the CSV file into the working directory. Okay, great. This is useful again for getting rid of those spaces in the names when we bring it back into R, and also useful for sending CSV files or Excel files to colleagues if they for some reason want that, you know, data in that format. Maybe they don't use R, unlike you guys who are using R. And maybe they want to work in Excel. After you've done cleaning on the data in R. Okay, great. So we don't need to change anything to this. Notice in Excel that message comes up even if you widen the columns. Alright, now going back to the Plankton data, we have this problem with the spaces. So let's read in the data now and see what happens. We're going to call it Plankton data 2. We're going to bring in that CSV as a read.csv instead of a write.csv. Okay, And here it's just the same thing. We take that part and we put that in the quotation marks. Providing this is directly in that folder, that's all you ever need to do. We're going to view the Plankton data 2 now and see if there's any changes to it. Okay, great. You see that the spaces have been replaced by dots in the names. And that makes our life easier for ggplot and for some other things in dplyr as well. At this point, we won't do too much analysis, if any, of the data in this data frame, although since I am a bit of a Plankton fan, I'm pretty sure I'll come back to this in the future. For now, I want to show you a cool library that I discovered recently, which is called skimr. And I'm always discovering new libraries because there's so many of them. You can already see through the packages on my computer just exactly how many I have. And again, some of these are installed when you install other libraries. Okay, but there's so many more and I'm discovering new ones all the time. The thing that I like about skimr is it gives you some sort of summary statistics on a data frame. Summary stats. Note though that I'm not going to get summary stats or try to get summary stats for 925 columns. That's going to take too long, probably. My computer can't hack that. So let's use tidyverse and dplyr in order to reduce the size of the data frame before we try and do any summary stats. Tidyverse. Okay, that's now loaded. You know, I noticed a student I had, when they installed the new version of base R, they lost some of the libraries on their computer and they had to install them again. That can happen, and there's tips for how to address that problem online. Let's reduce the data frame to just certain columns, okay? To certain columns. Which columns do we want? Well, we'll figure that out in a minute. First, we'll get the syntax going for dplyr, the pipe function. And the syntax or the code for selecting. If we want to do multiple columns, in our subset we use the C here, and let me just choose what we want really. Okay, let's take this species here, Tripos tenuis. Okay, Tripos tenuis. This is the method I'm usually using to select columns. I'm just typing their names in quotation marks in the brackets, in the orange brackets here. Let's go back and pick something like this, station code, and maybe year local. It doesn't really matter what order you put this in, you know. You can relocate columns if you want them to be in a specific order anyway. So we've got year local, year underscore local, and we've got station code with no underscore. If we type anything wrong, it'll tell us in a second. Year underscore local. Another option for select is that you choose the columns by numbers, okay, like 1, 2, 3, and that normally works as well. But we only want to choose 3 columns for the purpose of making the data set smaller here. And that was my bad. I forgot to put data in here, so it didn't know where to look. And here, this has worked. So now we view this new data frame, Plankton data 3, and we should have a much more manageable data frame now. Yeah, 3 columns, 1,431 rows. Okay, let's see what this Tripos tenuis goes up to about 500. probably again individuals or cells per meters cubed. We've got station codes here, and we already see that there's a lot of stations that have been sampled, and we've got the years that they were sampled there. Now we can use skim, okay, as part of the skimr library to get some more information about that data frame. So it's simple, it's just skim, okay, then the name of your data frame, just very similar to str, and that can be useful as well. Okay, skim. So this comes up in the console now, and what we're going to get is for numeric variables, okay, that's going to be year in this case and the abundance of this species. It's going to give us the mean, standard deviation, etc. For year local, we don't want that to be a number. Okay, ours considered it to be a number because 2018 looks like a number. For the purpose of grouping variables, it's better it's a factor, but we won't spend too much time on that today. For now, we can see that the mean of this species over all the rows is 1.86 plus and minus 22.2 standard deviation. You can also get information about the number of missing values, which is really useful. Quick check of how many missing values you have. And this is telling us a little bit, what we've already confirmed. One of the columns is character. That's going to be the station one. Any column that has any letters in it will be assigned to character variable, and the other two are treated as numbers. Again, these means here and standard deviations are those of the species. Tripos tenuis over all the rows, i.e. over all the years and all the stations. If you wanted to do further analysis of, for example, means per year of this species, you can just use the plier there, okay? So I'll call this tripos mean is based on this Plankton data free, and we can then use group within that to group it and get means for every year. So you're going to group underscore by year local. That's the first part of that. That will then be finished with another pipe function, and then do summarize here. Alright, we're going to create columns because we have to name the columns that we want to create, and there's lots of things you can put into the summarize codes. I think I've talked about this before. So things like you can use SD, you can use mean, you can use N for counts. Okay, we'll probably do all of those actually. This word here is the actual code. So I'm calling this column mean TT. That's going to be the name of the column in the new data frame that we're creating. This is the code that is part of the plier for part of tidyverse for calculating the mean. And now you write the name of this species. So tripos, and it starts to suggest it here. That will already give us a new data frame that will show one column, or two columns, sorry. Two columns, one column showing the years and the second column showing the mean of the species in that year. You can just add as much as you like to this to calculate other summary statistics. I mean, for the things that are included, okay? Like for example, we can do SDTT, and that one's easy as well. That's just SD and then the name of the species. Okay, and then we can do counts. Make a counts column, and that one's equals N open bracket, close bracket, just leaving the brackets empty there. Yeah, so now we've added all that information in there. And that again, just used by using write.csv. can be sent to someone if they just want summary statistics. So note that skim is useful, but it's only going to calculate entire column statistics. At least the code that we've had. I'm sure it's possible to add to it, to maybe group by. I haven't done that yet, so I didn't want to do that today. For this purpose, I'm normally just using group by within dplyr. Okay, the next thing I wanted to talk about was tables. Okay, so there's a lot of libraries that allow you to make nice, pretty looking tables in R. And the main ones are probably, that I use, are probably flextable and GT and also DT. Okay, so let's have a look at what those libraries can do with our new data frame. Okay, I'm gonna rename this to be tripos stats probably, because there's multiple columns in there with different measurements. And then we can try and make a table of that. And the reason why I want to do this is because if you publish, you're always going to at least include in your publication a few tables. And those tables, they often contain things like the counts and the means and the summary statistics. They might also contain the metadata about your station, but you're gonna need a combination of tables and graphs in your papers. If they don't go into the main text, they will go into the appendix. Okay, let's have a look at some of the libraries. I won't do too much with customization, maybe just a couple of things. There's a library called DT, and then the code to show a table for that one is data table. Let's see, it's just data table, all one word, data table, the name of the data frame, tripos stats. Notice that it still remembered tripos mean from when we made it before, okay? But we want tripos stats. Okay, all the tables used that we make here are going to show up in the viewer tab. And I actually like this one because here you can use the drop down menu to show how many rows you want to show. There's not going to be any nice customizations in any of these appearance wise unless we do it ourselves. You could easily go back to Google and just type in like DT something like this, data table R. It will maybe take us, it might take us to a GitHub page, or you can go to another website and DT, and it will tell us more about customizations and appearance. Like, wow. So this is what I would typically do here. I'd use color to highlight certain values, especially if it's a table I've made of p-values, okay? If you got, you make a model and you get the p-values for different variables in the model, okay? If they're significant or not on the response. Maybe I put the ones that are less than p-values less than 0.05 in one color, and those that are above 0.05 in another color. So there's just so much you can do with this kind of stuff, but it just takes a bit of Googling. Again, I like the fact that you can choose how many rows you want to show, and I like that you can use the up and down to sort or arrange by the row with the highest value in this column and the row with the lowest value in this column, just like you can do in the original data frame. So yeah, that's kind of cool. Again, you'd have to push next or previous if you've got too many columns to show, but you can also search for stuff here. So imagine we just want to search for 2017. Yeah, that's great. You can just get the data straight away. Yeah, so I guess I jumped to probably the best one first, because the GT library, which is one that I'm commonly using, but it doesn't have that search thing. And personally, I kind of like that search thing, but you can tell me what you think. GT library is another library for tables. If you just write GT here and the name of the data frame, tripos stats. Yeah, I use this sometimes, and it's just going to put all the data, on the same page. You can scroll up and down. You can export as an image. Okay. Okay, the problem with doing that is we might not be able to get it all on the screen at one time. Let's see. If we save that, and I'll just call this GT. Okay. Yeah, so of course if you save it as an image, we don't have that scroll bar. You have other options as well. You can go here, okay? Yeah, and then that's going to put it as like in your browser. You could potentially just use a snipping tool or something like this. The main thing about that is that if you want to do customization in this, it uses dplyr. So when you do the pipe function, after the pipe function, you put fmt, you can do this formatting here. All of this is part of GT here. We can do format underscore number 2. This will give us 2 decimal places for the various numerical columns. So let's try that. Yeah. Okay, it didn't seem to work in every case. It did it for the mean here. I'm not sure why it didn't do it for the standard deviations here. So I haven't done any customization to this yet. I've shown you how we can, get it, using snipping tool or something like this. We also can have a look at the website for this one. There's, well, not the website, there's a website which I've just Googled, okay? And you can do a lot of customization in this to make it look nice, like tab header and stuff. So I'm just gonna copy and paste this into the code. We use the pipe function here, okay? So the pipe function is dplyr, you're gonna need that running too. And they've made a title for this table called What a Nice Title. Notice these asterisks here. We'll see what that does in a second. And they made a subtitle as well. So we're just going to run all this. It's put the words that are in 2 asterisks in bold. And it's also put the ones that are in 1 asterisk in italics. That's very similar to what you do in R Markdown. Okay, so we'll talk more about R Markdown later. That's what we use for making reports, using something like this, new file R Markdown. We can make reports without ever having to use Word. Feel free to just go on websites like this and do customization according to your own preference. Okay, you can add labels. So we could add tab spanner here. It's something like this, right? So if you want to create a new label above certain columns, you can add another pipe function. This is what you want your label to say. So we can call this, like, we can make a label above the 2 columns, or the 3 columns, mean, TT, SD, TT, and counts, and we'll call that summary stats. And then you just write their names here, just like we did in any other time that we've used C, like for example here in select. I'll put these in quotation marks. I always use quotation marks for selecting where possible. It's just a habit. Now you don't really want spaces in them anyway, so it might not be essential. Sorry, not year local. Year local is not what we want. We want mean.tt, we want SDTT. This can be a little bit pernickety sometimes because, what happened to my mouse? We sometimes get situations where we miss a quotation mark afterwards and it can cause some confusion. Okay, so we've created that. We're going to create a label in a new row, okay, above the current column names. And that label is going to be called summary stats. And it's going to go above these three columns here. So let's try this now. So we've got a label that's been added here called summary stats. And you can also do a lot of other customizations using websites like that. And I think that's all I was going to talk about today. If you want to make tables for a specific purpose, you might have to follow the style of the journal, and that will include things like number of decimal places, whether they use APA formatting and stuff like this. They also, in this one, do use color to specify certain values, okay, and that's great. Oh, there's one other library that I often use, which is called flextable. And that's probably pretty similar. There's a lot of libraries now for tables on the internet, in R. So this is probably not going to do too much more than what GT can do, but we'll try it. Yeah, so it's a different format in here by default. We wouldn't want the years local to be 2009. Nothing has been done here in terms of like automatic number decimal places as far as I can see, but all that stuff can just be checked by going on one of the websites. So I hope that helped, A, with showing you how to overcome the message that library is not available for a specific version of base R, and B, for introducing you to the Plankton data frame, which is pretty useful. And I love the idea that because all these are numeric columns, we could plot so many species on the same graph and do multivariate statistics and stuff like this. And then for, making tables and calculating summary statistics with two methods, either whole column statistics or group statistics, and putting them in a table. So I hope this was helpful to you. If it was, please let me know in the comments. And next time I want to do something with color in graphs. There's libraries that you can use for that, as well as kind of old scale stuff that you put in sjPlot. Now, what I haven't really talked about before is the recommended order for code in sjPlot. We know about the first lines. When it gets to later lines, sometimes people just add them in wherever, like theme lines and theme changes. It's important that if you have like a certain template, like theme_pubr or theme_classic, that goes before other customizations that you want to make. So we will spend a bit of time looking at sjPlot code again, and until then, I wish you the best. Bye.